Hi, this is a lab 4, motion of a spring mass system. The main fundamental principle used in this lab is the Newton's second law of motion, momentum principle, and the energy principle. In this lab, we examine the motion of a spring mass system which moves in both x direction and y direction, and construct a computer model and compare it with the actual motion of the system. The Newton's second law of motion is final velocity is equal to initial velocity plus f net over mass multiplied by delta t, and the momentum principle is delta p is equal to f net multiplied by delta t. We can also find the position of the object by using this equation. The final position is equal to initial position plus velocity of the object times delta t. And the energy principle is that the total energy of the system delta E is equal to the kinetic energy plus potential gravitational energy plus potential spring energy. For this level, we performed an experiment with the mass of the object is 0.042 kg. The initial position is 0, and the initial velocity is 0, initial position is this, and a time is equal to 0 second, and the relaxed length L is 0.702 meter. Finding the spring stiffness. The time period is the time required for the complete one revolution, and it's equal to time t is equal to 2 pi under root m by k, and we approximate time observed from the graph using a tracker is 1.615 seconds, and substitute this value in the rearranged form of the above equation. We get the value of stiffness K, which is equal to 6.1 Newton per meter. By using tracker, we perform an experiment in which the object moves or oscillates up and down. On the left, we have the x values, and these are the y value position of the y values and x values. We store these values in Google spreadsheet and convert it into the CSV file. Here is the graph where this blue line shows the position of the object in the x-axis, and this gray line represents the position of the object in the y-axis. We using these values, we construct a computational model by using VPython by inputting the ball of the mass 20.40 kg, the initial position, initial velocity, and the g is equal to 9.8 Newton per meter square. This is the stiffness constant 6.1 meter per second. This is the L0 0.0542, which we measure by this. For a steady equilibrium condition, the force due to gravity and force due to the spring constant is equal to constant, and we can find the stretch length L0 is 0.0542 meter, and we are putting value of this here. These are the initial condition, and this is the total time, and the F net is equal to force due to the gravity plus force due to the spring, and force due to the spring is equal to stiffness constant K times S, which is the difference of the relaxed length, stretch length minus relaxed length, or compressed length minus stretch length into the L hat, which is the direction, and the force due to gravity is equal to the mg. Negative sign shows that it moves in the opposite direction, moves downward, and these are the Newton second law of motion and the position vector. When we run the VPython, we will see that the blue, the red the line shows the object real position, and the blue line shows the model position, and we can find and there is a change because there is something affecting on the and now we have go to the our model system is energy principle is satisfied. Delta E is equal to delta K plus delta U, the potential energy due to gravity, potential energy due to the spring, and the kinetic energy. The sum of these two is equal to 0. Okay, these are these instructions of the V-Python. When we run the V-Python, the green line represents the potential energy to gravity, red line will show the potential energy to stiffness, spring constant, blue line shows the kinetic energy, and the yellow line shows the total energy is equal to 0. The next version is using data obtained from taker, make two separate estimates of the oscillation period. First by estimating the period of the oscillation from the x position data, and second estimate the period of the oscillation from y position data. And here it is equal to in x direction 1.615 seconds and y direction is 1.559 seconds. The difference is this because the effect of gravity is stronger in y direction, causes the oscillation to occur in a short period of time.